Hello everyone, and welcome back to another video. Today we're going to discuss the uses of var, @onReadyVar, and @ExportVar, and when would be a good time to use them. I'll break down the difference using one simple variable that I'm sure we've all used before, speed. To illustrate this, I'll show you how I made this simple enemy chase the player. The enemy has three phases: not chasing, where the enemy's speed is set to 0, a chase mode where the enemy follows the player, and a catch-up mode where if the player gets too far away from the enemy speeds up and catches up to the player. Okay, let's get started. In this video, we'll be looking at rich text label node and animated sprite 2D node. We will also take a look at groups, and in the script, we will look at helper functions like getGravity, getFirstNodeInGroup, and Godot methods like distance_to, and take a look at the conditionals if, else if, and else. First, let's take a look at var, @ExportVar, and @onReadyVar, and see when they are used. Var is used when you just need a variable in your script. It gets initialized when the script loads. It's perfect for internal logic like movement or timers that don't need to be touched in the editor. So you use it when the value never changes outside the script, or you don't need to reference nodes. @ExportVar is used to expose a variable to the editor, so you can tweak it without changing the actual script. This is great for other devs that you collaborate with or yourself, in the case you want to tweak the player's speed easily. So use @export when you want to customize values or you want flexibility from the editor. Use @onReadyVar when the variable depends on a node in the scene tree. Let's say you have a rich text label node and you would like to change its value at runtime. @onReady makes sure that the node exists before assigning the value. It's evaluated after ready is called, so it avoids null references. So use it when you need to get values from other nodes or you want to cache a reference. An example of this is @onReady RTL distance or @onReady RTL speed in my example. Let's take a practical look at this. In the player script, we can create an exported variable for speed. Now in the physics process function, first I check if the player is not on the floor by using the conditional not, and the built-in method is on floor, and apply the gravity set by Godot's physics system, which can be found in the project settings using the helper method getGravity. Now I could set my own value for gravity, but because this is just an example, I chose to do it this way. I know this is less flexible because the gravity value is determined by the system, but we'll address this later. Then I create an internal variable for direction. Since this variable is not needed to be accessed anywhere else in the script, or the game for that matter, then set the internal variable direction equal to input.getAccess and pass in the input left and right, which returns a value for 1 for right and -1 for left, and 0 if no key is pressed. This input also needs to be set up in the project settings. I check if there is a direction, that is, an input is pressed, and set the player's x velocity equal to direction multiplied by the player's speed, and use the conditional else to check when there's no input. When there's no input, I use move towards to stop the player's movement. Move towards does this by moving the current value, velocity.x, towards the target speed 0, by at most the player's speed, and call the method moveAndSlide, which enables these functions to work. I used an exported variable for speed. That way, I can adjust the player's speed in the inspector instead of having to change it directly in the code. On a side note, if you wanted to have a deceleration for the player movement, then you could simply use a smaller value like 10 instead of the player speed variable in the move towards method. That way, the player would slowly come to a stop when there's no input. The enemy is a lot more interesting. It has different states, and I use the word states very loosely here. First, there's an idle state where the enemy does not move. When the player moves and gets a certain distance away from the enemy will start moving towards the player at a certain speed. If the distance between the enemy and the player increases further, the enemy's speed also increases, simulating the catch-up state. If the player stops moving and the distance between the player is reduced, then the enemy's speed is also reduced. And finally, if the distance is reduced further, the enemy stops moving altogether. I use this mechanic to make my entry to the Microjam 037 Food Game Jam. In my game, there's a Munch Monster that chases the player along the level. The Munch Monster increases and decreases its speed based on the distance of the Munch Monster to the player. I also added bushes that the player could hide behind that cause the Munch Monster to get confused and stop moving. This is all part of a future video that I'm working on, where I challenge myself to make a game only using signals. This was a really cool project, and I had a lot of fun making it. So, why not consider subscribing if that's something you may be interested in watching? Also, if you want to play Escape the Munch Monster, the link to the game's itch page is in the description. Okay, enough of that. Now back to the video. Now that you know basically how it works, let's take a look at the code. I will use @onReady variables to get references to the rich text labels for speed and distance, which I will use to display the speed of the enemy and the distance of the enemy to the player. I also used an @onReady variable for the player that I will assign the type of node 2D. I made variables for enemy speed and gave it a float value of 200 and max speed and gave it a float value of 500. I also made a variable for default speed and set it to be a float, but I did not assign a value to it. In the ready function, I can then assign the default enemy speed equal to the enemy speed. Then I find the first node in the scene that belongs to the group named player and assigned it to the player variable. Now before we move on, let's take a look at this. It's important not to confuse the relationship between @onReady variable and the ready function. While both are related to the node becoming ready in the scene tree, @onReady is used to initialize variables, usually with reference to child nodes, and it runs one time at the moment the node is ready. On the other hand, funcReady is a callback function where you write custom logic that also runs once when the node is fully added to the scene tree. Okay, that being said, if we did not assign the default enemy speed equal to the enemy speed in the ready callback function, and instead used an @onReady variable called default enemy speed as a float and assigned it to the enemy speed, the code works in the exact same way. There are no errors. It's fine to use, but in this specific case, it's not necessary, and might even be slightly misleading. You see, as I mentioned before, @onReady is used for node references if you're accessing a node in the scene tree, but in this case, we're not accessing any nodes, although this line implies that we are. In this case, we're just copying the value of a regular variable, enemy speed, that is already available before ready, so there's no real benefit to using @onReady here. A better way would be to remove @onReady and assign it that way. This works because the enemy speed and the default enemy speed are regular script level variables. However, this will only work if the enemy speed is assigned a value directly, like in this case, enemy speed equal 200. If the enemy speed were coming from the editor or calculated later, this assignment would not work. So the most flexible and clear way would be to assign the variable in the ready callback function. This avoids any confusion, shows clearly where the default is being stored, and works even if the enemy speed changes dynamically before ready. With all that cleared up, let's move on. In the physics process callback function, we first check if there is a player, and then make a local variable distance, and assign it to the position.distance2 and pass in the player's global position. This line calculates the distance between the current node, which is the enemy, and the player's global position. Then update the RTL distance text to show the word distance and formats the distance with 1 decimal point. After, check if the player is far away, more than 500 pixels from the player, and accelerates the enemy in the X direction using the max speed by delta. The else if condition checks when the player is 200 pixels or less, and the enemy stops moving by adding 0 to the X position by delta. The else condition checks when the player is between 500 and 200 pixels from the player, and accelerates the player in the X direction using the default speed by delta. Then, as before, we update the RTL speed text to show the word speed and the speed of the enemy, and formats the speed with 1 decimal point. And that's it. Super easy. Now you should know the difference between when to use var, @exportvar, and @onReadyVar. But these scripts are a bit limited and was only designed to illustrate the explanations. Let's add more functionality with only a few lines of code. This is going to be a really quick update. First, the player. Let's add a jump ability and a way to customize the player's gravity and have the player face the direction it's moving in. We can add exported variables for jump speed and gravity, and get an onReady reference for the player's animated sprite. In the physics process callback function, if the player is not on the floor, we can apply this new gravity variable to the y velocity of the player. As mentioned at the start of this video, this line is checking if the player is pressing the left or right movement keys. If the player is holding right, direction will be 1. If the player is holding left, it will be -1. And if nothing is pressed, it returns 0. So it gives you a clean way to know which way the player wants to go. So if direction is greater than 0, the flip H property of the animated sprite is set to false. Else, it is set to true, and the sprite is flipped, enabling the player to face the direction it's moving in. In the input event callback function, which checks for input, we check if the player is on the floor and if the jump button is pressed, and apply the jump speed to the player's y velocity. And just like that, we have a player that's more responsive, is able to jump and face in the direction it's moving. But the enemy is still not very responsive to changes with the player. So let's fix that. Now for the enemy, and this is really cool. We will have the enemy chase the player around the scene. First, we get an @onReady reference to the enemy's animated sprite, and we could also export the enemy speed and max speed to the inspector for easier adjustments. In the physics process function, we check if the distance to the player is greater than 500 pixels and set the enemy speed equal to the max speed. Else if the distance is less than or equal to 200 pixels, then we set the enemy speed equal to 0. And if none of these conditions are true, meaning the player is at a distance between 500 and 200 pixels, we set the enemy speed equal to the default enemy speed. And lastly, move the enemy towards the player and flip the enemy sprite so that it's always facing the direction of the player. Position represents the current position of the enemy in the game world. Player.globalPosition is where the player is located in the world. So we can use position.moveTowards, which makes the enemy move towards the player's position. The speed at which the enemy moves towards the player is controlled by enemy speed multiplied by delta. The multiplication by delta ensures that the movement is smooth and consistent regardless of frame rate. If you don't multiply by delta, the movement speed would be frame rate dependent, which means that the player could move faster or slower depending on how fast the game is running. And lastly, flipping the enemy sprite so it faces the player. Player.globalPosition.x is the player's X position in the world. Position.x is the enemy's current X position. So if the player is to the left of the enemy, meaning the player.globalPosition.x is less than position.x, we flip the enemy's sprite horizontally by setting the flip H property of the enemy anim sprite to true. This makes the enemy face to the left. If the player is to the right, the enemy sprite stays facing right, with flip H set to false. This combines the position checking and sprite flipping into one single line. Thanks for watching. We discussed a lot today. Core mechanics with no gimmicks. From the uses of variables and some built-in helper functions in Godot to if, else if, and else conditionals. I do hope this video was helpful to you in some way. If you liked the video, give it a like, subscribe, and turn on notifications so you'll know when I upload another video. And speaking of my other videos, why not check out one of my other videos here, like this great video on how to reuse your UI in multiple projects. Or head over to my itch page and give my game Escape the Munch Monster a try. This has been Diragu Games.